Greetings. Today I want to talk to you about multimeters. So you have with me today two multimeters, right? So you may be wondering, what is a multimeter? A multimeter is a device that contains 3 meters in one unit. So contained within this one unit, there is an ohm meter, an ammeter, and a voltmeter. And if I should refer you back to our basic automotive electricity classes, right? When we looked at the elements of electricity, we looked at voltage, we looked at current, and we looked at resistance, right? So this unit here, right, can measure both resistance, current, right, or amperage or voltage, right, within a circuit. So I'm going to show you how to set the meter up, right, to measure both voltage, current, and resistance within a particular circuit, right? So here with me today, right, there are two different types of multimeters, right? But they will be doing the same thing. Just the setting up of them is a little bit different, right? So this one is a little bit more expensive than this one here. This is an auto range multimeter here, right? So we're going to start off by showing you how to set up the meter to measure voltage, within a circuit. So this is our multimeter here, right? Again. So if we want to measure voltage, right, we'd have to switch the dial here. So this is just switching dial here, whatever unit that we want to measure, right? We switch it to the voltage settings right here. So now our meter, now our digital multimeter, now it is a voltmeter, right? And if you look closely at this one here, right, we are seeing a DC voltage being displayed on our screen right there of the multimeter, right? So if we wanted to measure AC voltage on this meter, we just have to just press that select button right here, and it is now configured to measure AC voltage. But we are dealing with automotive circuitry, which is DC, right? DC voltage and current that is flowing through our automotive circuitry. Right? So we're going to set the meter to the DC, right? DC voltage setting right there. Okay. So just get our battery back in view there. All right. So now we have to get our multimeter leads. So these are our multimeter connections here, our multimeter leads. So where these leads are placed on the multimeter, it is very important, right? So if you look closely at this meter here, right, you are seeing 1, 2, 3, 4 slots, and this multimeter here, 4 slots, right? So our black lead is always placed in the common slot, and if you should look a little bit close, right, on the common slot right here, you can see that it is also black, right, telling you that the black lead should always be placed in the common slot, right? So you place the black lead in the common slot, or your negative lead in the common slot, and because we're going to measure for voltage, right, we're going to place our red lead into the slot that is denoted for voltage, and which is this slot right here. As you can see, that little V right there and that little omega sign. That little omega sign is the symbol for resistance or ohms, right? So we're going to place our red lead into that slot right there. Right? So now our meter is now ready to measure voltage. So let's say we were using this little meter right here, this little one right here, right? So again, we would have to switch the dial and configure the digital multimeter here to measure voltage. But if you should look at this meter here, we are seeing 2 voltage set up on this meter. We are seeing one here and one here, right? So one of these, so this one over here is for DC voltage, right? And how do I know it's for DC voltage? If you take a look at the unbroken line up here and that broken dashed line underneath here, that is the symbol for DC current or DC voltage, and this little wavy sign that you're seeing on this one, that is the symbol for AC current or AC voltage, right? Alright, so we'll switch our dial over here to the 20 volt range right here, because our battery is approximately 12.6 volts, so the 20 volt range is good for us. And again, we'll take our black lead and place it in the common slot. And again, on this multimeter here, the common slot denoted with the black. You look down deep down in there, it's that black right there, that black color. You just place your black lead here, right? And you will place your red multimeter lead in the voltage, again in the voltage slash ohm slash milliamperage slot right here. And then now our multimeter now is now configured to measure voltage. Right? So it is now configured to measure voltage. Whenever we are measuring for voltage, how the meter is connected to the circuit is very important. Our meter must be connected in series with the circuit. Sorry, not series, but in parallel with the circuit. Not series, but parallel with the circuit, students. Right? So we are going to take our multimeter, we're going to measure the voltage at this load right here. So I've configured a simple circuit here, simple light bulb circuit that you're seeing displayed right here. So let's just bring it over a little bit closer for you. Right? So this is how we're going to make our parallel connections. Right? So we're going to make our connections right here. So you make that connection like that. And as you can see on our displayed on our multimeter, turn on the light, displayed on the multimeter there, you see about 12 volts, 11.97, about 12 volts right there. So this is the parallel connection. If we were going to measure the voltage at the battery, this is how we would make our parallel connection, right? Just like that. One lead there, and that is how we make our parallel connection, right? We can also make the parallel connection, connect the meter in parallel with the circuit a different way. We could just connect our black lead to battery negative, right? Like so. Connect our multimeter lead to battery negative. So this is battery negative over here. Connect our the black lead to battery negative. And use the red lead to probe the positive side of the circuit, and our meter is now connected in parallel with the circuit. As you can see, we are displaying 12 volts right there, right, on our meter. So this is how you measure voltage within the circuit. So now I'm going to show you how to measure current flow, amperage, right, the amount of current that is flowing through the circuit. So we're going to use this circuit here for our demonstration. The connections, how the meter is connected to the circuit when we are measuring for voltage. The meter must be connected in series, not parallel this time, but in series with the circuit. So the current must flow from the battery through the meter, through the load here, the bulb, right, and back to the battery, in order for us to measure the amount of current that is flowing through the circuit. And again, we are going to configure our multimeter to measure for our amperage. So if you look at this multimeter here and this multimeter right here, over here, this is our settings, right, for amperage. So we'd have to just switch our dial, right, over to this slot right here. But knowing this light bulb here, this light bulb draws probably about 3 amperes of current. So we're just going to switch it to the 10 amp range, right? So we are now at the 10 amp range on this multimeter. But something is off here, right? So we need to switch one of these leads. Again, our multimeter black lead, the black lead is always placed in the common slot. So we're going to move the red lead, and we're going to put it over to the 10 amp DC slot. And it is DC because we are measuring the current flow within the circuit here, and we are using a DC battery. Right? So our battery produces DC current, right, and voltage. So we'd have to put it on that DC, put it in that DC slot there. So this is how we're going to make that parallel, not parallel, but or series connections, right? So in order to make that series, connect the meter in series with the circuit, we need to open up the circuit, right? So we can open up the circuit either on the negative or on the positive side. So I'm just going to do it on the negative side just for convenience here. Alright, so I'm just going to open the circuit right here. So as you can see, the light bulb is out now. So I'm just going to connect the black multimeter lead to this part of the circuit here, and I'm going to connect the red lead to this end of the circuit right here. Right, and as you can see, the circuit is now completed because the current is now flowing through my meter through the light bulb. And we are now reading the amperage, the amount of amperage that this bulb here is drawing. And as you can see, we are having a reading of around 2.5 amperes there on our meter. So we can show it to you again one more time. You can see, right? And we are making that series connection. We are connecting the meter in series. So the meter is connected in series here. Alright, and displayed on our meter, it is 2.5 amperes. Alright, of current. So we could have easily have gone ahead and connect the meter in series on the positive side of the circuit. All we have to do is open the circuit again. Again, when you are connecting the meter in series with the circuit must be open. So we just connect the red lead here and make that connection here. And again, you can see on the multimeter here, right, we are showing a amperage reading of 2.5 amperes of current flow through this circuit. So in other words, this bulb here is drawing 2.5 amperes of current. So that is how current flow is measured within a circuit. Again, when you are measuring current flow within a circuit, the meter must be connected in series with the circuit. Alright? So now we are going to measure the last one here, resistance. Right? Whenever you are measuring resistance, right, of any load or any component within a circuit, the circuit must be de-energized. So the circuit must be off, right? And preferably the load is disconnected from the circuit. So we must disconnect the load from the circuit. So we're going to measure the resistance value for this light bulb here. So we're going to de-energize our circuit. So we're going to turn our circuit off. Or we're going to disconnect our load, right, from the circuit. So we take the load out of the circuit. But now, as you can see on our multimeter here was configured to measure amperage. So now we need to configure it to measure resistance. So we're going to remove the red lead from this slot and place it in the slot that is designated for measuring resistance or ohms. You place it in that slot there, and we also need to configure it further by switching the dial here to the ohm slot. So now we are at 200 kilo ohms, but this bulb here does not have that amount of resistance. So we're going to put it on that 200 resistance scale right there. And we're just going to connect our multimeter leads to the ends here of these two ends for a light bulb here. So we're just going to make that connections, and we're going to observe the reading on our multimeter. So let's turn on the light here. So you can see there's around 2.9, around 2.9. Around 1, yeah. Yes, it is now settled. Around 1 ohms, right, of resistance within this light bulb circuit here. So let us try it with this meter over here. So we're going to configure this meter here, right, to measure the resistance value for that light bulb, right. So we're just going to set it onto this scale right here. I configured here. So this horseshoe symbol right here, this omega sign, is a symbol for resistance here. So we're now configured to measure resistance, right? So we're going to connect our leads again, and once more the black lead is placed in the common slot. The red lead is placed in the slot that is designated for voltage and resistance on this meter here. take a close look, it is this slot right here. Right, so we're going to place the red lead, connect the red lead to that slot right there. And right now we're going to measure the resistance with this meter here of this bulb, slide bulb. Alright, so we're making the connections like so, and as you can see, we have that we are seeing 2.7 ohms of resistance, right, or 3 thereabout on this slide bulb from this meter here. So let's try it once more with the other meter. This meter here is a better meter. Just a little disclaimer here, this meter here is a more expensive meter than this one here. So this meter here will give us a better reading than this cheap multimeter here. So let us try it again with this meter. Right, and we are getting that 2.9. You can see 2.9 ohms of resistance right there. So let us turn on the light so you can see a little better. Right, yeah, so that's roughly what we're getting on this meter here. Alright, so that is how you measure the resistance within a load or a component using your digital multimeter. One last check that I want to show you with the multimeter is a continuity check. So if you look at the multimeter here, there's a little speaker symbol here on the multimeter. So there's a speaker symbol right here. Right, so that's for continuity. So when you're measuring continuity, you're checking for any breakage within any conductor or any wire. Right, so we can check it is always recommended that before you conduct any checks with your multimeter, you must the multimeter leads must be checked to ensure that there's no breakage within them. So I failed to mention that earlier. I'm mentioning it now. Right, so we should touch them together like that, and I hear that beeping sound. I will say that it's telling us that there is continuity within our leads. So our leads are okay. We can do the same thing for our light bulb here. So if our light bulb was blown, right, let's say we're unable to see the bulb filament, we could use a continuity setting, set the meter to the continuity setting, right, to determine if it was blown. So it does make a connection like that again. And with the meter beeping like that, telling us that the bulb here is not blown, right? It's the same thing for this meter here, but the only difference, right, on this meter here would have to select the continuity or the continuity setting, right? So we select the meter until there's a speaker thing right there, symbol right there is now showing. So now this meter here is now configured to measure test for continuity. So guys, so that is how you use your digital multimeter. So the steps and procedures that I've outlined here, right, for using the digital multimeter can be applied to any circuitry on the motor vehicle, right, when you're measuring for voltage, current, and resistance. So the main takeaway here that we need to understand is that whenever we are measuring like for current, resistance, and so on, the black lead is always placed in the common slot of the meter, regardless of which meter you are using. The black lead is always placed in the common slot, and the red lead is the lead that moves from slot to slot. So if you are going to measure current flow, the red lead has to move to the slot on the meter that is designed to measure the flow of current. And if you are going to measure for voltage, it must be moved to that slot that is designed to measure the voltage, right, within that circuitry, right? Or if you're going to measure the resistance, right, the red lead should be placed in that particular slot that is designated for measuring resistance. And also the switching, right? The setting of our our dial and the multimeter. When you're measuring voltage, put it on the voltage scale, the voltage setting, resistance, and so on. And the connections, right? When you're measuring current flow, the meter must be connected in series with the circuit, right? When you're measuring voltage, the meter must have a parallel connection with the circuit. And for resistance, when you're measuring resistance, we need to de-energize the circuit, right? And remove the load from the circuit and test the load, right, by itself. So that's it, gentlemen, right, and ladies. Thanks for watching.